feature for determining the limits, you got to really look at what they're giving you. So if you see that you have radical, then it is important that you can use the conjugate. So when you see radical, think of conjugate. Okay? So we're going to have to write that. Radical is square root. We call that the radical. Then you're going to think of conjugate. Okay? So now we're going to take a look at an example that have that situation. So here I have the limit as x approach 5 of x squared minus 25. Divide that by the square root of x minus the square root of 5. Now, the first thing is we're going to plug in. We're going to substitute 5 in for x. But when we plug in 5, you can see that we have a denominator of 0 and also a numerator of 0. So therefore, this is called indeterminate. Are we good? So here, this problem is indeterminate. Okay, this is called indeterminate. Indeterminate form. Okay. Indeterminate form there's two forms. It's either 0 over 0 or infinity over infinity. Is that good? We don't really write 0 over 0 because mathematically it is incorrect to write that. Is that good? So what you do once you have indeterminate form is you're going to try to rewrite it by using that conjugate idea. So based on that, notice in the last lesson, our radical is on the numerator. Okay? But in this case, our radical is in the denominator. It does not matter where it is. What matters is you got to try to multiply by the conjugate. So in this case, I'm going to multiply that by the square root of x plus the square root of 5. And I'm going to do that to the top and the bottom. Okay? We're going to zoom in for this one so you can see it. Once we have that, we're going to find out what this is once we multiply. Make sure you know, as long as I don't plug in the 5, I still have to keep writing that LIM, that limit. Okay? Once you plug in the 5, then you can forego the writing the LIM. So here, this is the limit. Yeah? As x approach 5. Now, this one, I'm going to leave it like that. I don't want to distribute and multiply. Okay? Your numerator, you leave it alone. So I'm going to write x squared minus 25 and multiply that by the square root of x plus the square root of 5. So we're going to leave it like that. Now, we're going to multiply these two. Understand that when you look at conjugate, your sum will cancel out. So therefore, you only have to multiply the square root of x with the square root of x, and then negative root 5 times the root 5. Do you guys see that? Your middle term will cancel, so don't bother multiplying it. So the square root of x times the square root of x will give you x. Are you guys good? Negative root 5 times a positive root 5 is negative 5. Are we all right with that, or do I need to show you why it's x minus 5? Yes. Because this is the one that I want to write the conjugate for. This is the square root of x minus the square root of 5. So what you want is to multiply that by the conjugate of this, which is root x plus root 5. No, like I said, in the previous problem when we did 1.6, the radical is on the numerator. So I said at the beginning that it does not matter if the radical is on the denominator or the numerator. You need to try to get rid of that one. Okay, that's by the conjugate. That's your first attempt. Okay, if that attempt works, you should be able to move forward. If it doesn't work, then you got to try something else. Okay, now that we have that, if I plug in a 5, that still doesn't work for me. You guys see it? But now you're going to have to see that the x squared minus 25, you can factor that out. Do you guys see that? And once you factor it out, it should be able to cancel with the x minus 5 on the denominator. Because the x squared minus 25 is x minus 5, x plus 5. There you go. And then this is going to be times the square root of x plus the square root of 5. Everything divided by the quantity of x minus 5. Now you can see that I can simplify this out. By simplify that, I no longer have indeterminate form because the factors that make my denominator a 0 is gone. Do you guys see that? So now what I can do is I can really plug in that 5 now. You guys see it? Once I plug in the 5, then I don't have to write the LIM. Okay? So I'm going to go over here, and I'm going to do just that. So equal. Probably have to zoom out a little bit so I can see the problem. Here you go. So I'm going to get, if I plug in the 5, that's going to be 5 plus 5 times the square root of 5 plus the square root of 5. Okay? So that's going to give me, that's 10. Root 5, add another root 5 is 2 root 5. So make sure you know that. These are like terms. So when you add the coefficient in front of it. If you don't have it, it is a 1. Okay, so 1 root 5 plus another 1 root 5, that is 2 root 5. So then if I were to multiply, I can take the 10 times the 2. Because the 5 is a radicand, is inside the radical, inside the square root. You cannot multiply it. You can only multiply the outside with the outside, or if you have another square root here, then you can multiply with that square root inside. Okay? So what you're going to get is 20 root 5. And that's your answer. Any questions on that? Okay, so again, when you see radical, try multiply by the conjugate first. Are we all right? Okay, let's take a look at example 2. Now, example 2 takes us back to trigonometry, okay? It's asked you to evaluate the limit as x approach pi over 2 of 1 minus sine square of x divided by cosine of x. We want to see what this is. The first thing is we're going to plug in pi over 2, yes? But what we want to do is we want to make a little unit circle. Here's pi over 2. This is pi over 2, right? The coordinate at pi over 2, hopefully you know, is 0, 1. You go 0, and then you go up 1. That's your coordinate. Yeah? So based on that, I know that cosine of pi over 2 is 0. Cosine is the x value. Yes? So last year we talked about that, right? Cosine is x. Sine of pi over 2, that's y. So that's the 1. Are we good? So based on that, I know that if I plug this in, cosine of pi over 2, that's a 0. Sine of pi over 2 is 1. 1 square. See, notice this is square. 1 square is still 1. So 1 minus 1, that's a 0 again. You guys see that? So you have a situation again, 0 over 0. So this is indeterminate form. One more time. You guys see that? So then what we're going to do is we're going to write that. This is called indeterminate form. Okay? When you have that 0 over 0, it means you got to find another way to find your limits. That's it. How are we doing? Okay. Now, the reason that I like this problem is because I know you don't remember how to do this one. The idea is you got to be able to rewrite this thing. Okay? So if you remember back in pre-cal last year, there's that problem 4 where they asked you to rewrite your trick, remember? Yeah? So the idea is you got to rewrite it. Now, here's how you rewrite them. You got to look at the 1 and see how can I rewrite that. Or you're going to look at the sine square and see how you can rewrite that. Is that good? But I'm going to rewrite the 1. So you're going to make sure you recall, okay, that sine square of x plus cosine square of x is equal to 1. This is the Pythagorean identities. Is that all right? Now, if you don't remember, know that now. Okay? So see that 1 right there? I'm going to replace that 1 with sine square plus cosine square. I'm going to replace that 1 with sine square plus cosine square. So we're going to do that down here because I don't have enough space here. So this is the limit as x approach pi over 2. And that 1, now I'm going to replace that with sine square of x plus cosine square of x. Minus, now I'm going to rewrite the rest of the problem as they're giving it to me, like so. Are you guys good? Now, why do I do that? Well, because now I can see that sine square of x can be subtract with the sine square of x, and that would make 0. That would cancel out. And therefore, I would only get now this. This cancel with that, so I would have cosine square of x divided by cosine of x. Are you guys good? Yes? So now if I clean that up, you're going to see that I can cancel out one cosines of x. So if I cancel out one of them, I'm going to get cosine of x. There you go. And that's why we do this. So in the end, we can cancel out the square and then the cosine. Okay? What you have is just cosine of x. Once your ratio is gone, now you can plug in pi over 2. So cosine of pi over 2. Again, once you plug in the value, you can forego the writing the limit. Cosine of pi over 2, we have it up here. It is 0. So your answer is 0. How are we doing? Question? Okay, let's do the last one. Now it says, evaluate algebraically limit as x approach 1 of the square root of x minus 1 divided by x squared minus 1. Again, in this case, you see your radical. You guys see that? So that's your hint. You're going to have to make sure you can rewrite it using conjugate. Okay? But we want to check first, is this indeterminate form? If I plug in a 1 for x, I'll get 0 for the denominator. If I plug in the 1 for the square root of x, I will get 0 for the numerator. So again, this is indeterminate form. So we're going to write that. This is one more time. Indeterminate form. Because again, you get that 0 over 0. Now, when you, later on, there's a shortcut to finding the limits, okay? But you have to learn Unit 2 first before you can learn that shortcut. Is that good? So in the meantime, this is what we have to do. Is that all right? All right, go ahead and multiply by the conjugate for me. Starting right here, go ahead and multiply by the conjugate and see if you can get that answer. Go ahead and try. Go ahead and try. So let's see what we got. So I have the square root of x plus 1 times the square root of x plus 1. That's your conjugate. So make sure you look at the two terms, write them the same. but make sure the signs are opposite. That way it will cause your sum to be 0. All right, let's clean this up. So when I multiply the square root of x with the square root of x, I'll get x. -1 times 1 is a -1. So on my numerator, that's what I got. Now, I'm going to try and fast track this. I'm going to factor this out. Hopefully you can see that it's x squared minus 1. So that's going to be x minus 1 and x plus 1. Okay? And then what I have here is the square root of x plus 1. So now you can see that, hey, I can cancel x minus 1 and x minus 1. And notice, this is the term that's going to cause my indeterminate form. So once you have that, I'm going to clean this up one last time before I plug it in. Hopefully you're okay with that. I'm going to write the limit again, because I'm not plugging in the 1 yet. I just want you to see the clean form of it. So what I got is 1 divided by x plus 1, and then the square root of x plus 1. Notice, when you cancel, that does not automatically mean that this thing is left, and therefore you can bring it up. You cannot. This is in the denominator. It has to stay there. All right? Once you have that, now we can safely say, okay, I can plug in the 1 now. Once I plug in the 1 into x, I can forego my limit symbol. So now we're going to plug in or substitute in the 1. So we're going to get 1 plus 1 times the square root of 1 plus 1. So we can see that, oh, I got 1 here. 1 plus 1 is 2. And then the square root of 1 is 1 plus 1 is also 2. So my answer is 1, 4. Questions on that?